The ASE Suspension and Steering Test, also known as A4, will test your ability to diagnose and troubleshoot the systems that are used to make a vehicle handle safely under all driving conditions. The four test areas for A4 are steering systems diagnosis and repair, including steering columns, manual and power-assisted steering units, and steering linkages. Suspension systems diagnosis and repair, including front and rear suspensions and miscellaneous services, wheel alignment diagnosis, including adjustment and repair, and wheel and tire diagnosis and repair. Since not all task areas are covered in the video, use the available reference books such as manufacturer service manuals, technical training manuals, and textbooks to help bring you up to speed before taking the ASE A4 test. After viewing this video, you should be able to diagnose hard or loose steering complaints, diagnose handling problems, diagnose tire wear problems, and diagnose suspension noises. Steering systems diagnosis and repair should begin with a complete inspection of the steering system. You can often find the cause of steering problems simply by looking around. Rarely, if ever, do you find a problem with a steering wheel, but chances are you will have to remove a steering wheel to access the other parts of the steering column that do require repair. Before you start any work on a steering column, you should know all of the safety precautions you should take when working on an SRS airbag-equipped vehicle. Make sure you disconnect both battery cables and wait at least 10 minutes to allow the airbag's capacitor to discharge before you attempt to work near or remove an airbag. Most steering columns used today consist of a tilt mechanism that lets the driver adjust the angle of the steering wheel, and the shafts and couplings that transfer the rotation of the steering wheel to the steering gear or rack. Start your diagnosis by moving the steering wheel up and down and side to side. There should be very little, if any, movement in the column. Keep in mind when troubleshooting steering columns that the two most common complaints on steering columns are noise and excessive play. Clunking or popping noises usually come from the couplings between the shafts or from loose column mountings. Worn steering shafts and couplings will also cause hard steering effort and a binding feeling when turning. Excessive movement in the column will come from worn components in the tilt mechanism, worn contact surfaces on the column, or from loose mountings. There are two common types of steering gears found today: the traditional steering gears, either manual or power-assisted, and manual and power-assisted rack and pinion units. For manual steering units, whether they are the worm and roller type or the recirculating ball type, follow the procedures in the service manuals to adjust worm bearing preload, gear mesh preload, and sector shaft lash when rebuilding the gear unit. When troubleshooting steering gear problems, remember if there is too much preload or too little lash, the steering will feel stiff or tight. Too little preload or too much lash will result in too much free play and a loose feeling in the steering. Power steering gears have one more adjustment. The control valve must be centered. If the valve is not centered, the car may drift or pull or have poor steering wheel return in one direction. Only spool-type valves can be centered. Rotary control valves must be replaced if they are not positioned properly. Most adjustments to traditional steering gears require the removal of the steering gear from the vehicle. Only the worm-bearing preload can be done on the vehicle. When removing the steering gear, always mark the relationship of the pitman arm to the sector shaft, and always use the proper puller to remove the pitman arm. The parts of the steering linkage used on traditional steering gear systems are the idler arm, the intermediate shaft or center link, and the tie rods. Wear in any of these parts will cause excessive free play, not to mention excessive or abnormal tire wear, vibrations, or loose steering. Diagnosing these parts is as simple as pushing on them with your hand to check for excessive movement. Always replace worn or damaged parts. Rack and pinion systems differ from traditional steering gears in that they don't use the elaborate linkage systems that traditional steering gear systems use to turn the wheels. To diagnose a rack and pinion problem, start with an inspection of the rack and pinion steering unit. Check for loose or worn mounts that can cause the rack to move or vibrate. If the mounts and rack alignment are okay, the problem can be inside the rack and pinion assembly. Most shops replace the rack assembly when there is an internal problem. The exception is the repair of leaking rack end seals. If a steering rack boot is full of fluid, you can bet an end seal is leaking and must be replaced. Replacement requires the unit be removed from the vehicle. Checking a power assist steering system is simple. You need to check the power steering pump, the drive belt, and the power steering hoses. When diagnosing a power steering system, use a pressure test. Pay attention to the peak pressure. The expected peak pressure is usually around 1500 psi. Pressure readings significantly above that indicate a system restriction or a bad flow control valve. Pressures below that indicate internal leaks that must be repaired. When working on power steering pumps, follow the procedures in the service manual to remove and replace the pump. Adjust belt tension, replace leaking seals and gaskets on the pump and hoses, and when bleeding the air from the system. When diagnosing handling and ride problems, both the front and rear suspension systems should be inspected. Front suspension systems come in many various forms, from traditional coil spring suspensions to the popular McPherson struts. Other systems, such as torsion bar systems, leaf springs, and twin I-beams are also used. The primary functions of the front suspension are to fix the location of the front wheels and to keep them on the road. Secondary functions are to reduce body roll in corners, to provide a comfortable ride, and to keep the ride height proportionate front to rear. Coil spring suspensions achieve these goals using upper and lower control arms, ball joints, and anti-roll or stabilizer bars. The control arms are carried in bushings, as is the stabilizer bar and drop links. Troubleshooting suspension problems relies on your ability to verify the condition to get to the root cause of the problem. When diagnosing suspension noises, always start by inspecting the bushings. Worn bushings allow the components they carry to move in their mounts, causing metal-to-metal noises. Worn bushings usually cause noise during suspension movement, and they must be replaced. If the bushings are okay, look towards the ball joints. Bad ball joints will cause wandering, looseness in the steering, or excessive wheel bounce. Many ball joints have wear indicators that will tell you when they're beyond their usable life. Whenever you work on ball joints, remember to unload the tension on a ball joint before attempting to replace it. Don't overlook the coil springs when troubleshooting suspension noises. Springs that have shifted in their seats or worn through the insulators will cause noise. Weak coil springs will cause the car to sag or to pitch forward on braking. Weak coil springs affect ride height and must be replaced. The most common front suspension for front-wheel drive vehicles is the McPherson strut suspension. Diagnosing problems with McPherson struts comes down to knowing your noises. If the noise occurs over bumps, it can be a bad spring insulator, or a weak strut cartridge. Special spring compressors are required to replace the strut cartridge. Troubleshooting noises on turns usually shows a problem with the top strut bearing. Coil suspensions use shock absorbers to keep the wheels on the road. When troubleshooting problems with traditional shock absorbers, use the Jounce test. Push the suspect side of the car up and down a few times. Stop and watch the rebound. A vehicle that rebounds more than 1 1/2 times will need to have the shocks replaced. Diagnosing torsion bar problems again relies on your ability to verify the complaint. Torsion bars that are weak will cause excessive lean or differences in ride height, or they can cause a popping noise over bumps. Procedures for diagnosing rear suspension complaints vary depending on whether the vehicle is front or rear-wheel drive. The rear suspension types are usually coil springs and shocks for rear-wheel drive vehicles, and modified McPherson struts or multi-link systems for front-wheel drive vehicles. Leaf springs may also be used on rear-wheel drive vehicles. When diagnosing noises, excessive body roll or ride height concerns, look for wear on the rear suspension components. When troubleshooting problems with any of the suspension systems, keep in mind which systems cause vibrations, which cause noise, or which cause poor handling, and isolate the cause of the problem from there. The area that is most likely to be misdiagnosed as a problem with a steering or suspension component is wheels and tires. Start your diagnosis of any steering or suspension concern by simply checking the tire pressure. Far and away the most frequent cause of hard steering effort, vehicle pull, tire wear, tire noise, and irregular ride height is simply low tire pressure. A front tire that is underinflated will cause a vehicle to pull to that side of the vehicle and wear the tire on the outer edges. Underinflated tires will also cause hard steering effort. A front tire that is overinflated will cause the vehicle to drift or pull to the opposite and wear the tread in the center of the tire. Rear tires that are over or underinflated will cause the same wear patterns and often cause uneven braking or cause the vehicle to wander. If the tires are properly inflated, continue your diagnosis by looking for mismatched or incorrect tire sizes or types that can cause similar handling problems. Use the DOT numbers and tire specifications stamped into the sidewall of the tire to confirm the proper application and load rating of the tires. If the air pressure and tires are correct for the vehicle, you'll need to look further in your diagnosis for problems with tire balance, which will cause vibrations in the car or the steering wheel, wheel lug nut torque, which will cause the wheels to wobble from excessive lateral runout or cause warping of the brake rotors, causing brake pulsations, wheel runout, both radial runout, which will cause a shimmy, and lateral runout, which will cause a wobble, tire runout, both radial and lateral, and rear axle hub runout, which can cause the same problems as improper lug nut torque or excessive lateral wheel or tire runout. If you are unsure how to check any of these problems, be sure to refer to the procedures in the service manual. With the exception of balancing, all of the previous problems will require new tires or the replacement of worn or damaged parts. A good diagnostic aid for tire wear complaints are the wear pattern charts found in most good service manuals or textbooks. You can save some time troubleshooting tire wear problems by using these resources. A properly set four-wheel alignment keeps the vehicle handling neutral and the car going straight under acceleration, braking, and normal cruise conditions. When steering, wheel alignment plays a major part in holding the car on line through the radius of the turn. Misalignment of the front or rear wheels can cause the car to wander, drift, or pull going straight, or to bump steer, have hard steering effort, or have poor steering wheel return when turning. And improper alignment will cause all types of tire wear. Before checking the alignment, make certain the tire pressures and vehicle ride height are correct. If you're diagnosing a tire wear problem, start by checking the alignment angles that will cause tire wear, toe and camber. Toe in and toe out refer to the position of the front of each tire to the center line of the vehicle. Tires that are closer to the center line at the front than they are at the back are toed in. Typically, alignment specifications call for a slight toe-in setting because the front of the wheels will push out to zero toe at speed. Excessive toe-in will wear the outer edges of the tires. Toe-out is abnormal and must be corrected. Toe-out will wear the inner shoulders of the tires. Toe is adjusted with the tie rod and adjusters. The steering wheel is also centered using this adjustment. Camber is the relative position of the top of each tire to the vertical center line of the vehicle. Where the top of the tire is closer to the center line than the bottom, the camber is negative. A slight amount of negative camber is usual, as the top of the tires will move out with speed. Excessive negative camber will cause the tires to ride and wear on the inside edge. Positive camber is abnormal and will cause the tires to ride and wear on the outer edge. Where camber is adjustable, it is usually adjusted using shims or cams on the upper control arms. Camber is usually not adjustable on front-wheel drive cars. Where it is, the adjustment is made by moving the position of the front strut in its mount. Caster will not cause tire wear, but will cause problems with steering effort, wheel shimmy, wandering, and pulling during straight-ahead driving. If you're troubleshooting a caster problem on a front-wheel drive car, remember caster is not adjustable on most of today's front-wheel drive vehicles. Inspect the suspension for bent or damaged parts and replace them to correct out-of-spec conditions. Adding and removing shims on the upper control arms will correct both camber and caster on most rear-wheel drive cars. You can adjust the rear-wheel toe on most front-wheel drive vehicles by moving concentric cams or by adding or subtracting shims. Some vehicles require shims to adjust toe and camber in the rear. There are specific shim designs for specific vehicles. If there are no structural problems or damaged suspension or axle components, adjusting the rear wheel toe will correct an incorrect rear wheel thrust angle. As we have seen, the ASE A4 suspension and steering test will cover all of the interrelated systems necessary to make a car ride and handle safely. If you're uncomfortable with any of the areas we've covered in this video, pick up one of the excellent ASE test guides or training manuals on suspension and steering systems and take the time to further prepare for the test. Thanks for watching and good luck on the test.